All right. Now, graphing these logarithms. If there's any sort of shift or change or whatever, it's best to do these just using a graphing calculator. But let's just keep in mind here, completely unshifted, no matter what the base was, it looks something like this. And it hits at 1, 0. So this is kind of the general shape of the logarithm. Now it's going to be shifted, and the asymptote, if you remember what that means, a line that gets close to but never crosses, might not be the y-axis anymore, and you might not hit here anymore. So it's best just to use your graphing calculator. So on 1, we'll go y equals. Now, math for anything other than a 10 or an E for a base, we go to math, choice A, log base. Base is 2. X minus 1. Minus 5. Now we'll take, maybe if you want, take a look at it. Oh, okay, so you can see it's going to be down here somewhere. Now to get some points, let's go second table. Let's only pick out some of the points we know are whole numbers. So 2, negative 5, and then 5, negative 3, and let's see. Over to 9, nope, that won't fit on here. Now, one thing that you can kind of check, normally the asymptote is the y-axis. That, again, that's where it shoots up and down and it won't ever actually touch. We know that's going to be right 1. So instead of being closer and closer and closer to the y-axis, we're going to be closer and closer to y equals 1, which is this vertical line right there. So then you just draw your shape in. There we go. And you can see that here anyway. Here's 1, and it starts going almost vertical right at x equals 1. So on 2, let's just keep in mind here, if this is shifted 2 over, our asymptote is going to be over 2. So we're going to come and almost hit that x equals 2. Well, let's see. Y equals, just to remind you where the log base is, math. You can either go all the way down or hit up. Log base, this is base 4. X minus 2, hit over, minus 1. Second table. We got 3, negative 1, right there. Let's find some whole numbers. 6, 0, right there. And like we've already said, since this is shifted 2 to the right, we're going to get real close to the vertical line x equals 2. And you can see that on the graph. It even just kind of disappears. Sometimes your calculator can't handle things when they're almost vertical. And if you're wondering why, it's because vertical lines aren't functions. Now, I'll let you do 3. I wanted to skip to 4 just to mention inside, remember it's a shift left or right. This is actually going to be left 2. And I wanted to mention that, so there's our asymptote. On the pack of Regents questions, it says the graph, the graph of y equals log x lies in quadrants. We picked choice 4 because this was unshifted. So the shifts can move it out of that range. So let's take a look. Let's see if we can fit anything on. So if it's new, log base, but we've already done a couple here. So log x plus 2 plus 4. Let's take a look at it. Oh, hey, there we go. So we can see your graph, the calculator starts having trouble right at x equals -2, the shifted asymptote there. So second table, -1, 4. We can fit that one on here, -1, 4. And then as we keep going through, 4, 5, that'll fit. 4, 5. And I don't think anymore. Nope, no more will fit. Starts going real slow. So again, the asymptote shoots up right here, comes right up. If you think about it going the other way, it'll head down there that way forever and ever and ever. It gets super close, but never actually hit this line. So this is how you graph logarithms. Pick out the whole numbers on your calculator's table, on your graphing calculator's table, and just try to keep in mind where the asymptote is going to be. Either from the shift, like here, this was left 2, so instead of the y-axis, the left 2, or from where your graph starts to kind of cut itself off. Again, this happens because your graphing calculator can't handle almost vertical lines, can't display things that aren't functional.